Welcome dear students to this lecture. Today we'll understand basic proportionality theorem. First we'll understand the concept of basic proportionality theorem and then we will prove the theorem. Children, basic proportionality theorem is very important of similarity chapter. So understand the concept properly so that you can do the sums related to basic proportionality theorem. If we take the first theorem, that is basic proportionality theorem. Now remember, theorems are very important for the entire chapters. So first let us remember the theorem and understand the theorem and then we'll try to prove it. Now what is a basic proportionality theorem? If a line parallel to a side of a triangle. Now here we have a triangle. Okay, A, B, C. If a line parallel to a side of a triangle. Now BC is a side and now you have a line here. This is line L. Intersects the remaining sides in two distinct points. Now it is intersecting AB in point P and AC in point Q. So intersects the remaining sides in two distinct points. Then the line divides the side in the same proportion. Now when it is dividing, intersecting in two distinct points, unique points, that means it is divides the line sides in the same proportion. What is the proportion? That is AP upon PB will be equal to AQ upon QC. Okay, this is the theorem. Once again, a line parallel to a side. Which line is parallel? Line L is parallel to a side. Which side? It's parallel to BC. Intersects the remaining two sides. So line L is intersecting the two remaining sides. Which are the two remaining sides? The remaining sides are AB and AC in two distinct points. Which are the two distinct points? P and Q. The line divides the side in the same proportion. Now this line is dividing the sides in the same proportion. Which sides? The sides are AB and which are the sides the line is dividing? It's dividing AB and this side which is AC in the same proportion. That means which proportion? AP upon PQ is equal to the proportion of AP upon PQ. We'll understand it in much better way. But you just remember that AP upon PQ, whatever is the value, now suppose this is 2 and PB is 4. Okay, so we'll write 2 upon 4. Now AP upon PQ has to be equal to AQ upon QC. So now AQ might be 3 and QC might be 6. So 3 ones are 3 and 2. So here 2 ones are 2, 2 ones are 2 and 2 twos are 4. So the proportion is the ratio is 1 upon 2 and this side is also ratio is 1 upon 2. Okay, so remember this. When a line parallel to a side intersects the remaining two sides. It's not intersecting this side BC, it is intersecting the remaining two sides at two distinct points. Which are the two distinct points? P and Q. Then it divides the line which it has intersected in the same proportion. So line divides AB and side AC in the same proportion or the same ratio. AP upon PB is equal to AQ upon QC. Okay, theorem we have understood. Now the proof is in triangle ABC, line L is parallel to line BC. Line L, this is line L which is parallel to BC. Line L intersects AB and AC in point P and Q respectively. Line L is intersecting line AB in point P. This line is intersecting AB in point P and AC in point Q. So it's getting intersected at 2 points It is named as P and Q. Now we have to prove that AP upon PB is equal to AQ upon QC. In order to prove that AP upon PB is equal to AQ upon QC, we have to do a small construction. Draw sec PC and sec BQ. So we are this construction is there, PC and BQ. Now we are going to take this triangle separately. The first triangle which we are going to take is, we are going to take the left side. Okay, this left side we are going to take, which I have drawn here, this left side, and then since it is slanted, I have taken it straight. Okay, so it becomes easier if you draw your diagram straight, so that you come to know what is the base and what is the height. So here we will have the first triangle. We are taking triangle APQ. APQ is here. Okay, I have taken this part, this triangle. I have taken this part of the triangle. Separately I have drawn here. Okay, and then each triangle I have drawn it here. That is, we are taking APQ. So we look at this figure APQ. In APQ, what is the base? Base is AP. Okay, and height is QX. The height is here. Okay, height is QX. Even here you can see the height is here QX. In triangle PQB, we are in second triangle PQB, and the triangle is here PQB. Okay, this is the second triangle, and it's even here it's there. So what is the base? Base is PB. Okay, if you look at this figure, the first figure, you will get little confused. That is why I have made the smaller figure, so that you know that base is down. Base is PB. Okay, and height is QX. The height is here. Now what can we say about this? Here you can see that the height for both the triangles are equal. Therefore we will take the A1 upon A2, which is equal to B1 upon B2. What is B1? B1 is the base of the first triangle, which is AP, and B2 is the base of the second triangle, which is PB. Now we will keep this as the first part. We have to take other triangles also, and then we will draw the conclusion about the basic proportionality theorem. Now we'll take this other part of the triangle. The second part we're going to take is APQ and PQC, which is on the right hand side. Okay, right hand side figure, the same figure I'll show you. This side. This is the figure. Okay, right hand side. This side of the figure we are going to take, and I have drawn it here. The right hand side figure is here, and we are taking two triangles APQ and PQC. APQ and PQC. Okay, so PQA is here, or APQ. Okay, we can read it as PQA or APQ. APQ is here, base is QA, and height is PX. See, height is here and base is here, QA. In triangle PQC, base is QC, base is here, QC, and height is PX. Height is PX. Now this is what sort of a triangle is it? It's an obtuse angle triangle. So the height is coming outside here, PX. So height is PX. So here again you have A1 upon A2 is equal to B1 upon B2. What is A1? A1 is this triangle APQ. Okay, area of triangle. Area of triangle APQ upon area of triangle, which is the second triangle. This is PQC triangle PQC. And what is base 1? Base 1 is QA upon base 2 is QC. Okay, this is the second part of the proof. Second part of the proof. This is the second part of the proof. Now we need to understand that PQB and PQC, they lie between two parallel lines, BC and line L and line BC. Okay, since these two triangles, PQB and PQC lie between two parallel lines, which are the lines line L and line C. So I will show you the figure PQB and PQC, this triangle. You can see PQB and PQC are lying between these two parallel lines. This is one parallel line, the other one is this parallel line. Anyway, I have drawn it neatly, but I just wanted to show you how the figure looks in the original diagram. So PQB and PQC is lying between these two lines, and therefore what happens when it is lying between the two lines? The heights are the same, right? But they also have, now remember, PQB is here and PQC is here. Now what is the common thing about them? You can see height is the same, so we are not going to take the height. Here you have P, Q, B, and here you have P, Q, C. So what is common? The common is this base PQ, right? So now the base is also the same, the height is also the same. So therefore these two triangles, triangle PQB and PQC, are equal. So we got the third point. The first 2 points we have got, and now we have got the third point. We have got equation 1, equation 2 and equation 3. Now we will try to correlate all of them in order to prove the theorem. First equation was what? Area of triangle APQ upon area of triangle PQB is equal to AP upon PB, which is the first equation. The second equation is area of triangle APQ upon area of triangle PQC, which is equal to AQ upon QC. This is the second equation. Okay, now compare the first equation and the second equation. You will find numerator here APQ in the first equation is equal to the numerator in the second equation, which is APQ. See here APQ and here also APQ. Now PQB is equal to PQC. In equation number 3, we have found that PQB is equal to PQC. So the denominator of the second equation is equal to the denominator of the first equation. So both numerator and denominator are equal or the same. Okay, I'll give an example. Now suppose the area of triangle APQ is 20 and area of triangle PQB is 25. Okay, this is the first equation, so you are getting 20 upon 25. And the second equation is APQ upon PQC, and we have said APQ is equal to APQ, so we will naturally get APQ on top. And we have said PQB is equal to PQC. Therefore, if this is 25, this also will be 25, right? So here we have 20 upon 25. Now when you cancel that, what will be the ratio? 5 4s are 20, 5 5s are 25. Same here. 5 4s are 20, 5 5s are, so the ratio is the same, that is left hand side APQ upon PQB is equal to APQ upon PQC, right? Because the numerator and the denominator values are the same. Now we have found that the ratio of each is 4 upon 5. Now what is 4 upon 5? After we are saying the left hand side is equal to right hand side here, right? What does this equal to sign mean? That the left hand side is equal to right hand side. That means if this is 4 upon 5, left hand side is 4 upon 5, right hand side will also be 4 upon 5. Here also APQ is 4 upon 5. Therefore, right hand side also will be 4 upon 5, right? So that means all the sides of values are 4 upon 5. That means the left hand side is equal to right hand side of this one, APQ upon PB. PB is equal to AQ upon QC. Once again, we have got APQ as the ratio of APQ upon PQB and APQ upon PQC as 4 upon 5, right? We have got it that APQ upon PQB, we have found it as is 20 upon 25, we have got it 4 upon 5, right? Now what is the equation? Have a look at the equations. I'll clean a part of it so that you all can understand what I'm trying to say. So we have got APQ upon PQB is equal to 20 upon 25, which is equal to 4 upon 5. Now APQ upon PQB is equal to what? AP upon PB is equal to AP upon PB. Naturally, all are equal, so this value will also be 4 upon 5. So the entire thing is now 4 upon 5. This is just an example. And next we said APQ upon PQC. We have said APQ is equal to APQ, so we have taken 20. PQC is 25 because PQB is equal to PQC, we have taken it as 25. When we cancel, we get 4 upon 5. Now APQ is equal to what? Is equal to AQC is equal to AQC, AQ upon QC, right? So that is also 4 upon 5. Now AQ upon QC and AP upon PB, all of them are 4 upon 5. That means AP upon PB is equal to AQ upon QC. Everything is 4 upon 5. From 1, 2 and 3, we have got AP upon PB is equal to AQ upon QC. Now what is AP? AP is here. AP upon PB. AP upon PB was there in the first equation. AQ upon QC. AQ, and this is QC. This is there in the second equation. That means the ratio of AP upon PB will be equal to AQ upon QC. When will it be equal? When a triangle is intersected by a line which is parallel to one side, parallel to this side. Therefore, the remaining two sides will be in proportion. So, this was basic proportionality theorem. Thank you, dear children, and God bless you always.